Hi everyone, this is Jane. Welcome to the inheritance webinar. So we're going to be spending about 30 plus minutes to go over inheritance and polymorphism concepts. And then the latter half, we're going to spend some time with writing code. Inheritance is an important concept of object-oriented programming, and it allows us to easily manage groups of similar objects. So that sounds pretty abstract. So what does that mean? Let's look at this example here. We're going to create a virtual world where a player can choose which vehicle to ride to explore the city. Here are the three vehicle objects. There's the electric scooter, a bicycle, and a car. We want to make sure that whichever vehicle the player selects, it's going to have common attributes and behaviors. So if you press right, the vehicle should turn right, and if you press certain key, it should move forward, and so on. So what common attributes do we need for each of the vehicle? In other words, are there certain data or status that we need to keep track of? So we'll probably need to keep track of fuel, which could be electric battery or human energy or gasoline. And we also need to know how fast the object can move, so let's also keep track of max speed. And you can see that these attributes can also be thought as nouns. Now let's add some common behaviors. What common behaviors or verbs can the objects perform? How about move and charge? So vehicles, of course, they move, and when we're low on fuel, we'll need to charge. So for the bicycle, that would be feeding the human. So these would be the common attributes and behaviors. However, these vehicles also have their own particular characteristics. So let's look at the scooter. How is it same and how is it different? So for the scooter, it comes in many different colors, so we may want to keep track of color. And also you can fold it, which can be written as a method. Then for the bicycle, as you can see in the picture, it's got a basket, and maybe some bicycles don't have a basket. So we'll keep track of has basket by setting that as a Boolean variable. And bicycles can also jump. A car may or may not have a sunroof, and it will definitely need a large parking space, so let's create a method called park. So you can see that the scooter, bicycle, and car can be something more than just a vehicle. And by using inheritance, we can manage these attributes in an organized way. Once the inheritance relationship is established, the scooter, the bicycle, and the car will inherit the attributes and the behaviors of the vehicle class. When this inheritance is formed, the vehicle class is called the superclass or the parent class. And the scooter, bicycle, and the car is a subclass or the child class. And these classes are in a is-a relationship. So for example, a scooter is a vehicle, a bicycle is a vehicle, and the car is a vehicle. Will the opposite work? A vehicle is a scooter. Not necessarily, right? So the opposite doesn't work. So you can say that a subclass is a type of a superclass, but not the other way around. And here is a diagram of the parent and children classes. A child class can be equivalent or do more and be more than the parent class. Let's look at how this relationship comes in handy. So we want to make the virtual world more challenging by creating situations where your vehicles can break. So there are now potholes, sticky gum, mud, and so on. So now our objects need to be able to deal with these challenges. So does that mean that we need to make changes to all of our classes? Nope. Because we're in a superclass subclass inheritance relationship, this update is going to be simple. All we have to do is make that change in the superclass vehicle. We'll keep track of the status broken with a Boolean instance variable, so true or false. Also, there should be a way to fix it, so add a method called fix. And when we do this to superclass vehicle, all subclasses inherit these updates automatically. How convenient. We also know that if we decide to add more vehicle subclasses such as motorcycle, jetpack, and a skateboard, that these will automatically inherit all of the things that the vehicle class has. So inheritance ensures consistency, and it provides a way to manage these classes in an organized way. So how do you create an inheritance relationship? It's easy. All you have to do is add extends superclass name in the subclass. Let's look at another example. Here are some superheroes that you may be familiar with. They're heroes from the Avengers. If you don't know them, still fine. If we were to create a superclass called superhero, what kind of attributes or behaviors should it have? So let's find the commonalities and list them. And here's what I think we should track. So a superhero should have a name, right? Iron Man, Captain America, Black Widow. And they also have a real name. So Hulk is actually Bruce Banner. And we also want to keep track of energy level. They can't be infinitely strong all the time. Then they'll also need to be able to move, right? Some of them fly, some of them run, and rest, right? We need to restore that energy. And of course, they're able to use special power. Next, let's pick one of the character and create a subclass. So you can pick from the Avengers character or from a different universe. Doesn't matter. So what additional attributes and behaviors should this subclass have? Try writing it down. For me, I picked Hulk. So he's got 2 additional attributes of Boolean green. Is green true or false? And we also need to keep track of the anger level. So the angrier he gets, the more powerful he gets. And we have special power once more. So if the method's already in the superclass, why is it necessary for Hulk to have its own? Well, this is called the overwriting. The same method in the superclass is overridden by the subclass method with the same call signatures. Later, when we start coding, we'll see this in action. So here is our coding project. Project Save the World. The goal is to create superhero subclass objects and have them use their special power all at once. Let's create the project from scratch, and I'm going to pull my editor from PopViz. If you have the Java course on PopViz, you have this editor too. If you have other software or other editors, that's fine. If you'd rather code in paper and pencil, that's okay too. Here's what I've created. A single Java file called superhero.java. It's got a superhero class with nothing inside it. If I run it, nothing will happen because I don't have a main method. And of course, the superhero class is a template, so it's not going to have a main method. This main method will live inside another class. If you're not familiar with how a class is created, make sure to refer to Chapter 5, Writing Classes. Before we start typing away, let's take a quick look at the attributes and the behaviors that we need to create the superhero. So we'll need string name, string real name, integer energy, and 3 methods, which are move, rest, and special power. The 3 attributes, name, real name, and energy, are going to be created as private instance variables, and we want to keep them private for security reasons. They're not going to be made accessible outside of this class. So private, string, name, and the values are not going to be assigned because it'll be assigned later as we construct the object. Private, string, real name. Last one, private, integer called energy. Oops. Then to construct objects out of this superhero template, we're going to need constructors. Public superhero, and of course the constructor is going to have the same name as the class name. By default, when the object is created, let's give it some energy to begin with. And we're going to create another constructor, and when we have 2 or more constructors, do you know what they're called? They're called the overloaded constructor. So here is our second constructor. And this one is going to set the name and real name instance variables. String n for name, string rn for real name. Instance variable name will be assigned n. Real name will be assigned rn. Then we need 3 methods. So public void move. This method will not return anything, but it'll simply print a statement. System.out.println, and it'll simply say superhero moving. Next one is the rest method. Public void rest, and I'll just copy the statement here, and instead of moving, it'll say resting. And here's the important method, public void special power, and this is going to simply say superhero special power. And let's create one more method. We're going to create a toString method, and it's going to return what's in the instance variable. So this method will be very useful for checking what's set as the instance variables. The toString method is a special method. So all classes created in Java inherently extends this class. So if you climb up the inheritance hierarchy, at the very top exists this class. Do you know what that is? It's the object class. And the object class has this toString method. So what we're going to be doing here is we're going to override the toString method in the object class with our own. So public, and it's going to return a string, and it's called toString. Oops. Return name space is space real name with energy level, and then concatenate energy. So this method will come in handy when we want to check what's in the instance variable. Great, now our superhero.java file is done. Next, we're going to create Hulk, the subclass. And let's quickly check what we need for Hulk. For Hulk, we're going to keep track of Boolean green and also its anger level in integer values. It's going to have 2 extra methods, special power and apologize. So Hulk tends to break a lot of things, so that apologize method would come in handy. Back to the editor. Let's create another file. This is going to be called hulk.java, and we'll put public class Hulk. Then we need to extend our superclass. So let's use the keyword extends, and then insert the superclass name superhero. It's going to have 2 instance variables. First one is Boolean green. Second one is int anger level. And this will also need constructors to create objects. We're going to create 2 constructors. One is going to be empty. And here is our second constructor, public Hulk. And this one is going to set all the instance variables, including the name, the real name, whether it's green or not, and how angry it is. So all that's going to be set when this constructor is called. So it'll have string name, string real name, Boolean G for green, int AL for anger level. And then what do? So we have string name and real name, but we don't have an instance variable under Hulk to assign it. The name and real name is actually set from the parent constructor. So if we can use this constructor, which takes name and real name, we don't have to repeat the code for Hulk. This means that we need to be able to call the parent constructor and pass in name and real name from here. How do we do that? We do that by using keyword super. And super is a way for a child class to call the parent class. So it's basically saying mom and dad. So mom and dad, please set name and real name. And the rest, we can set it here. Green is set to G. Anger level is set to AL. Great. Now we need to create the two methods. So one is the apologize method, which is going to be public void apologize. And it's simply going to print I'm sorry. Next is the special power, public void special power, and system out.println Hulk is going to say arg, and then kapow. Now we know that there is special power for Hulk and there is special power method for superhero. And Hulk is going to override the special power method because it needs its own way to express its special power. So Hulk is not going to say superhero special power. It's probably going to groan and scream and yell. So it makes sense to override it. So our superclass and subclass are done. Next, let's run the program. And the class that has the main method, there's a naming convention for those. They usually have runner in their name. So we'll just call this file runner.java. Public class runner. It's going to have a main method, public static void main string args. Inside, we're going to instantiate Hulk object from the Hulk class. How do we do that? First, we put the reference variable type Hulk, give it a name, we'll call it Hulk1. Maybe there are more Hulks out there. This is Hulk1. New Hulk. And this would create the Hulk object by calling the empty constructor. And you know that when constructor is called, it's going to go up the hierarchy to the superclass, and we'll call the empty constructor from here. And to check to see that the object is created properly, we're going to use the toString method created in the superhero.java. And because we don't have toString method under Hulk, when we call toString on Hulk1, it's going to find that toString method from superhero.java. Let's call toString on Hulk1 and see if we're going on the right track. So system.out.println. Inside it, we'll do Hulk.toString. Oops, Hulk1 toString. But toString method is special. So when you try to print the object, you know what happens, right? It's going to give you the memory location of where that object lives. But because we have our own toString method, it's not going to print the memory location. And we can remove Tostring Method, print the object itself, and this should work. I'm going to select my run file and run. And of course, we haven't set the name nor the real name, so it's going to have the default values null, right? Null is null with energy level 5. So this 5 is set, meaning that the empty constructor, Hulk, has called the empty constructor superhero and set the energy to 5. Now let's try creating an object using the second overloaded constructor. So this time we're going to pass in name, real name, whether it's green or not, and its anger level. And this Hulk is going to be Hulk 2, new Hulk. The full name is the Incredible Hulk. Real name is Bruce. And to begin with, Bruce is not green, and nor is he angry, so 0. And let's see what this prints. So system.out println Hulk number 2. Let's run the code. Oh no, silly error. Should have been the lowercase h. All right, run. There we go. The Incredible Hulk is Bruce with energy level 0. Excellent, that worked. Now, Hulk's special power is not going to be enough to save the world, so we're going to have to add more superheroes. And we can copy what's in Hulk and then create Black Widow. Paste. I'm going to trim everything that we don't need. So we're just going to keep the special power method. And let's change the class name to Black Widow. Also, we need to override the special power. Black Widow's got great agility, she's cunning, and she's got the Widow's Bite. And let's add one more. This time, let's add Thor. Oops, Thor.java. And change the class name to Thor. And Thor will yell Asgardian strength. All right, so we now have Hulk, Black Widow, and Thor subclasses. Great, now we're going to create these objects from the runner class. And let me remove everything that's here. So we're going to put Black Widow, Widow 1, assign it new Black Widow, create Thor, Thor 1, new Thor. Now we want to have Hulk, Widow, and Thor all using the special power at once. So how do we do that? Let's put them in an array and then using a for loop, call them to use special power. So let's create an array list, which is going to contain these objects. And we'll need to import java.util.arraylist. Now let's create the array list. Array list. And here's something that we should think about. So we know that array lists cannot have different types of objects. But Hulk is a Hulk, Black Widow's a Black Widow, and Thor is a Thor. So what object type can we put here? Well, thanks to inheritance, we don't need to worry about that. We can plug in superhero because all our subclasses extend superhero. And let's give it a name, the Avengers. new array list type superhero. And let's add the objects. The Avengers dot add, and we'll add Hulk1. And I'll copy this code and do the same for the rest of the objects. So Widow1 and Thor1. Next, we're going to loop through the array list, the Avengers, and for each element, we're going to call the method special power. For superhero S from the list the Avengers, for each object S, call special power. Let's run. Great, so it's working great. We have Hulk special power, Black Widow special power, and Thor's special power. One last thing, and we want to keep the reference variable type consistent, and at the same time, let the objects be its own type. So instead of Hulk, we're going to put superhero, and we can do the same for the rest. And now, just by looking at the runner file, we can see that Hulk is subclass of superhero, Black Widow, subclass of superhero, Thor, a subclass of superhero. And this is called the polymorphism. Poly meaning many, and morph has to do with form. So this would produce the same effect if I run it. However, putting the subclass type as the reference variable and the object as the superclass will not work. So Hulk1, new superhero is going to throw an error. And the error message says, incompatible types, superhero cannot be converted to Hulk. So a child could be more than what the parent is. And if you imagine variable type as a remote control controlling the superhero object, telling Hulk1 to apologize won't work because superhero doesn't have apologize method. So no matter how many times you press that apologize button from that remote control, superhero will not know what that means. So make sure to have your subclass or your child class as the object type. So that is it for today's webinar, and I'll pass the mic to Nisa. Thank you so much.